The electrical circuit is a fundamental system for energy transmission and the operation of electronic devices. In this context, the flow of charge is a key concept, as it describes the movement of electrons through a conductor under the influence of an electric field. Electric current, which is the amount of charge passing through a cross-section of a conductor per unit of time, is measured in amperes. In circuits, conduction electrons are responsible for this flow, moving in a pattern that depends on the applied potential difference. Additionally, conductive materials such as metals allow electrons to move easily, facilitating the flow of current. In electrical circuits, it is essential to understand the two main types, series and parallel. In series circuits, the components are connected one after the other, and the same current flows through each resistor, generating a voltage drop proportional to each component. On the other hand, in parallel circuits, the current is distributed among the branches, maintaining the same potential difference across all of them. In addition, Ohm's law, which relates voltage, current, and resistance, and Kirchhoff's laws, which describe how currents and voltages are distributed in a circuit, are analyzed. In short, this knowledge is essential for understanding the behavior of electrical and electronic devices and for the efficient design of circuits in industrial and domestic applications.